Okay, so counting principles. There are actually two main factors, which, as you can see to the right here, are permutations and combinations. So let's start off. Say there is 1, 2, 3. How many different ways can you arrange these? You can manually do it, and you'll see that there's 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, and 3, 2, 1. These are actually all the ways you can arrange 1, 2, 3. And this here is actually what you call it to be a permutation. So here you can see 6 permutations happening. Another way to calculate this would actually be 3 factorial. 3 factorial because there are 3 things you are looking at, 1, 2, 3. And in order to calculate this, you would just use the number 3 and multiply it by all the following values that come below it. So 3 times 2 times 1, which equals 6. So 6 permutations, it matches up. Same thing would happen if you're trying to find how many different ways 10 objects can be arranged. That would be 10 factorial. Or 4 objects, that would be 4 factorial. So 10 factorial, 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, that was unnecessary. Anywho, same thing with 4. 4 times 3 times 2 times 1. Combinations, on the other hand, are essentially the same thing. The only difference is that the arrangement or the order does not at all matter. So here you see 1, 2, 3, and 1, 3, 2. These are the same thing, actually, because the objects are essentially the same. See, let me give you a clearer example. Say there's 1, 2, 3, 4, actually. How many different ways can you pick 2 digits or 2 numbers from these 4? So that would be a combination. See, let's say there's 1, 2 for starters. There is 2, 1. There is 3, 2, 3, 4, 1, 3, 1, 2. There's a lot, right? So here, these 2 are actually permutations. There's a permutation happening, but it's just one combination because there's 2 different numbers. There's 2 same numbers being arranged differently, but these same numbers imply that it is only one combination. See, 2, 1 and 3, 2, on the other hand, are actually a combination. And how you would calculate how many combinations of 2 you could draw out, you would use this formula over here. So it would be written as, there's 4 numbers, so 4, and then you choose 2, which can also be written as 4 over 2, or 4, 2. 4 choose 2. And then you would just essentially plug it into the formula, so it would be 4 factorial over 2 factorial, and then 4 minus 2 factorial, which would be, just simplify, 2 factorial, 2 factorial. And you could use a little bit of algebra, so 4 times 3 times 2 times 1. And then, or let's get rid of that actually. It would be 2 factorial. And then 2 factorial times 2 factorial. We can get rid of these 2. 4 times 3 is 12. And then 2 factorial is 2. What's 12 divided by 2? 6. So there would be 6 different combinations that you could draw out. Let's go check some examples here, actually. So a lottery actually has 45 numbers, and if you buy a ticket, then you have to choose 6 of these numbers. And how many ways can you choose 6 numbers from 45? So this is actually a combinations question, because apparently in lotteries, the number or the values chosen don't matter. The order in which you choose them don't matter. It is just the digits themselves. So you would use the combinations formula. So you know you have 45 options, and then you choose 6 numbers, which can also be written as 45, choose 6. And it would be 45 factorial over 6 factorial, and then 45 minus 6 factorial. As you can see, that is the formula, so it matches up. And you could plug this one into a calculator because it's a really large number. 45 factorial over 6 factorial times 39 factorial. This next one, 15 drivers are taking part in a car race. How many different ways can the top 6 positions be filled? This is a permutations question because one guy can end up at first place, or they can end up at second or third, and it could just alternate. So it would be 15 drivers, and then you choose the top 6 positions, which would equal, and you use the formula above here, which is n factorial over n minus r factorial. So 15 factorial over 15 minus 6 factorial, which equals 15 factorial over 9 factorial. Of course, you can also use some algebra, so 15 times 14 times 13. Whoops. 12 times 11 times 10 times 9 over 9 factorial. Get rid of this. So you could use a calculator for this one as well. So it would be 15 times 14 times 13 times 12 times 11 times 10. And you'd be getting your answer. That is all. I would encourage some more practice outside of this video, and thank you.